Vectors in mechanics. A particle with mass 0.5 kilograms is initially at rest. Three forces act on the particle, and these forces are given in vector form. To work out the resultant force acting on the particle, we add these three forces together. So we need to add the I components together, we need to add their J components together, and we need to add their K components together. And when we simplify, we get this resultant force. Now we know that if there's a resultant force, then there will be acceleration. So F equals ma, so the F resultant will be equal to mass times acceleration. And we have the resultant force here, that goes there. The mass is in kilograms, it goes here. Then we can work out the acceleration. So far we have this. So dividing by 0.5 on both sides gives us the acceleration in vector form, meters per second squared. Now the acceleration is constant. We don't find any other terms in here. For example, that's not 10 times t, where t is time, for instance. These are all constants. The acceleration is a constant, so we can use Suvat formulae for other calculations. So the magnitude of the acceleration, so we're using Pythagoras' theorem, so we do the square root of 10 squared plus minus 2 squared plus minus 6 squared. So simplified, root 140, that's the exact acceleration, and we can round to three significant figures, so 11.8 meters per second squared, a constant value. Now to work out the distance the particle will travel in the first 6 seconds, we can use Suvat formulae. So S is what we're looking for. Initially it was at rest. The acceleration in its exact form is root 140. And t is 6. We're not interested in the velocity, so we need a formula without v. Substitute the values in. So the initial velocity is 0, so that term becomes 0. So we've got a half times the acceleration times t squared, and simplifying gives 213 meters.